Hello and welcome. Thank you for joining me on my GraphQL Galaxy talk, and I'll be talking about introspection, what it is, how it can be useful, and all those things. The idea for this talk actually came from when a colleague dragged me into a live stream where they wanted to figure out how they can get GraphQL query autocompletion into some API tooling. And I thought it might be interesting to just share some of the learnings with other folks as well. So who am I? My name is Stephan Schneider, and I've been working with APIs for roughly 5 years now, and have started working with GraphQL in 2018 when our company was building our first GraphQL API. Since then, I basically have never stopped working with it and want to give you some more details about introspection. So we do have this slight distinction that we have 1,000 schemas every month that we generate at Contentful, because our customers can define their own content model, and based on that we generate them a GraphQL API. And for that we also use introspection in some of our tests, and that will be quite interesting. So what is introspection and why should I care? Introspection is also a term used in psychology, and I really like those two terms about self-awareness and self-discoverability, and basically took them now to the technical part of introspection as well. So self-awareness means that your API knows which type it is working with and can give you those information about them. Self-discoverability means it's a standardized way that the server can make assumptions about your types and that you can use to actually fetch those types from the server. In comparison to REST, this is an upfront design decision of the language itself. On REST, you have to rely on that there might be some standard that an API is following, like the Open API spec, for example. If it doesn't comply to it, you basically have no more information about what kind of types it provided and have to rely on a good developer documentation being written. So let's look at a real-world example, and most of you have probably worked with it beforehand, GraphiQL. The GraphiQL interface is shipped with most of the server implementation that you have, and it allows you to issue queries against your GraphQL server. So here, for example, you can see we have all the types available that our Contentful schema knows about. For example, the Contentful metadata or the Contentful tag. Then for all of those types, it also knows about which fields you have available. And as you can see here, for example, also the descriptions of them. But not only that, you also have for all those fields, their types and their arguments to the types as well. So in the end, GraphQL knows about everything that your schema contains and can give you autocompletion for it. How does it work? Let me introduce you to a couple of types that you might have never seen before, because they're actually not part of your schema, but they are part of your schema. They are there implicitly. So here, for example, we have on the query field two more fields. On the query type, we have two more fields called __ schema and __ type. The two underscores means they are meant for internal use, and you are not allowed to create types that start with two underscores. They are owned by GraphQL as a language. Then we also have the type schema, which is returned when you query the __ schema type. The schema type then contains more fields that you can use for querying. You will see those later. For example, you can query for all the types, or even for a single type on the query object, and you will get information about that specific type, like its fields. Those are implicit. They mean they are never actually showing up in your schema. You don't have to write them yourself. And then there's also a bunch more. On this bunch more, I think the most interesting one is the __ type name. And you might have used them already when you have worked with interfaces or with union types. You can use them to differentiate which actual type is returned at runtime. So you in your result can reason about which of the 2 or 3 different types available you have actually received. They are also implicit, not part of your schema. So those introspection types, what does it mean that they're implicit? It means you don't have to write them. They will be there, and there's no way for you to forget about implementing them or implement them differently. So every type object will always have a fields field. And that field cannot be differently implemented. It is part of the implementation of the server that you are using. And if you don't stick to that implementation, well, you're basically not spec compliant. They give you, therefore, a standardized interface to work with the types in your system. And you can technically disable it, but you cannot remove them implicitly from your schema. So disabling here can be done in the GraphQL JS reference implementation, for example, via a so-called no schema introspection custom rule. Quite handy name, but it does imply it's a custom rule. With that, you are actually relying on the validation phase to disallow querying the schema or type properties or the other types that are there implicitly. By disallowing querying any of them, you have effectively removed them from your schema. But please take note that it doesn't mean your schema is now safe from being inspected. GraphQL is quite helpful when it comes to errors, and within those errors you get some did you mean completions. And those completions will still show up even if you have introspection disabled, so you could brute force your API to return you those names. So don't take it as a security measurement. Let's have a look on the introspection query. So this is the introspection query in a very shortened form, because the real one has over 100 lines, and yeah, that would be not really good to display here on a slide. So this is the brief form of it, and you can import it from the GraphQL JS reference implementation as well, and will give you basically everything that the type system knows about. So you can see it as like the full introspection query. What it does, it gives you all the types, the kind of the type, for example, whether it's an object, an enum, a directive, name, description, and if there is a variable, the fields are there. So they are really relying on the nullability feature of GraphQL. So every type will have the same shape, and you don't need to do like fragments or so to fetch them. They might be just null, then fields will just be null in the response, or in case of like objects, you will actually get the fields returned. So what we can also do is we can write our own introspection queries. As I said earlier in the introduction, at Contentful we are generating different schemas based on the customer input. So what we thought is quite handy would be to test that our generation assumptions actually hold true. So for a given input, we want to check that a specific set of types is generated. So what we did was we wrote our own introspection query, which we called here introspect all type names, which just gets us in the schema all their types and their names. And then in a test assertion, we can just check that, for example, the query or the test CT type are available in our API. With that, you can basically test all those assumptions with your own introspection queries without taking the full lengthy 100 lines of code one. So at this point, you might be wondering, well, we already have the schema definition language. Why can't we take this? And yes, this would be possible. So you could take the SDL string, you could parse it into the object types, and then you could work with them. But this is not really the nicest experience, and also there's another problem. GraphQL is language transport independent. So while it's usually served via HTTP, and it's so common there's even a GraphQL over HTTP spec, you technically could also use RPC calls, for example, or you could have like some WebSockets interactions. And on those, you also want to be able to get your introspection results. So what we can't do is to just create another HTTP endpoint, because those are not available on like RPC or WebSockets. So then you might be thinking, okay, we just could put them on a field somewhere. And yes, you can, and then basically just return a very lengthy string which contains your whole SDL. Actually, that is what Apollo is doing when you are using the federation. And in federation, you then have, I think it's called a service type, and on that service, you have an SDL field, which gives you the whole SDL string again. For me, that feels a bit hacky, but I do get the reasoning, and you will learn about that today as well. So schemas can often also get filtered or stitched and everything, and you only want to serve the real final one, and you would have to take care that you always serve back the correct one. But the stitched API in its introspection will always know about all the types that are stitched into it, and no mistake can happen. It cannot get out of sync. So commonalities and differences between SDL and the introspection, I think, is when it is nice to explain why it is so handy to have introspection around, and also to explain why we cannot use introspection for schema stitching. So when we have a schema, the GraphQL schema is like the domain type we are always working with. For example, when we pass it to like an Express GraphQL to the Apollo server, they all work in the background with a GraphQL schema object. GraphQL schema object can be used to execute queries against them, run validations against them, and so on. So usually you would build your schema from an SDL string and pass it to build schema. Build schema is provided by the GraphQL JS reference implementation as well, the same as all the other functions I'll be calling in this section. You can introspect its types on it then via introspection from schema, and you would get an introspection result which is the JSON response that you get, and you can look at it. The same that like GraphiQL, for example, would receive. And you can then even take the schema and print it again, and you would get the SDL out of it. Here, the white spaces are preserved because when you are parsing it from an SDL string, the types in the schema know about their position and their white spacing. So in the end, it should be a one-to-one representation of the initial string that you have passed. So far, so good. Let's look at how it works with introspection. So when you have an introspection result, like you can see here, it's just a plain JavaScript objects JSON style shape. And you can pass it into something called build client schema. This is also provided by GraphQL JS. Once you have passed it in there, you also are working with a schema, which means on that schema, you could call the print schema method again, and you would get an SDL string. This SDL string doesn't retain any white space because the introspection is not aware of it. So you just get the default formatting that you would get. What you can also do is you can take the schema that you've built from an introspection query and actually introspect it again. This one is then the full circle again, and the initial object that you have passed and the new one you get out should be deep equal. This means we have now learned we can actually take an SDL or an introspection thing and transform it into each other, which is pretty nifty already. So what are the differences then when we can just take both? Both can be a schema. Why do we have the two different ways? So on the SDL, we can have something called a directive defined. Here we have the add auth directive on a field. And then we can use this, for example, on a mixed access type. The mixed access type has a field which is public and everyone can access it. But it can also have private fields, which we just call private here for convenience. And this one can only be used by admins. So an add auth directive usage, where we say it can only be queried by an admin. So in the SDL, you will have this information retained. So you can build a schema out of it and print it back to a schema, to an SDL string. You will get those usages being preserved, and you know which field has which directives applied. In the introspection result, on the other hand, you won't see that. You will only know that there is a directive defined in the schema, but you will not know where it has been used. I personally think the reason for that is that directives can have some business logic that you don't want to see exposed, but there is also lengthy discussion going on in the GitHub repository. So if you feel strongly about it, feel free to chime in there, and maybe at one day we won't need the SDL string for using a federation or any other type of stitching. So to look on another pretty cool example of what you can do with introspection is GraphQL Tools. GraphQL Tools is built by the Guild. The Guild is doing a lot of awesome tooling around the GraphQL ecosystem. And it allows you to transform your schema in various ways. You could say we want to prefix all of our types with contentful because we are stitching it with, for example, the GitHub schema. And we don't want to have clashes on the types, so we just prefix them. No problem with that. You could also filter your schema to only expose specific types. Those tooling methods all work with basically the two primitives that GraphQL have defined, which is the schema or the document, aka the passed query string. A query gets always passed into a document, and then the document can be executed against the schema. So those are the two primitives, and how you can get to a schema is by using different loaders, and those loaders can take sources like a string, a file, or even a URL. And from all of these, it will generate you a schema that you can work with. So, loaders, examples you can see here. The easiest one is just the string, as we had in an earlier example. You can just throw the string in, and it will delegate under the hood to the build schema function, and now you have a schema available. It can also take a file, so that you don't need to read in the file by yourself before calling it, and you can use the file loader, pass it a schema.graphql file, it will read the file in, then uses the build schema method, and you have a schema again that you can work with. And I think the most interesting one for our talk here is the URL. So you can pass to load schema a URL of your GraphQL endpoint and use the URL loader. Once you've done that, what happens under the hood is that the GraphQL, like the full introspection query that GraphQL.js provides, is used and sent to your GraphQL endpoint to be executed there. Afterwards, the result is fed back into the build client schema, and you have a schema again. So it basically does exactly what I've shown you in more detail beforehand. So once you have a schema now, you can attach resolvers to them if you need to. If you really want to do execution or delegation or so, you can basically provide them with resolvers. At this point in time, there's basically no distinction for you anymore where that schema came from. You can just work with it. So to give you a recap of what we have just learned is that introspection provides you a standard way to work with your API and to work with the types it has. You can, but you actually don't need to write your own introspection query, and in fact most of the people are fine with just using the full introspection query the reference implementation provides. But if you ever need to, you can just query portions of your type system. The plain JSON result that we get, this introspection result, can be used to generate a lot of powerful tooling. So we can have interfaces for typed languages, like in JavaScript or in Java. We can get types out of them that we can then use to reason better about what we're actually working with. We can get a visual representation of our API schema and could see how different types relate to each other, which could be quite cool, and especially in a more complex model, that you can actually see, okay, this field points to this other type, and you can see how it flows through your system. We can get code completion, which is basically the reason of the talk, like GraphiQL does, that when you type, you will get all the field names that match to it, so you can use autocompletion and are aware which fields are available. And which is also pretty cool, you can use it in your CI or CD pipeline to take the new schema from your current code and compare it with what's currently on production, and you could detect any sort of breaking changes and have them automatically attached to your pull request, for example. And there is even a tooling for that, I think even from the guild, that does exactly this. And the introspection result can generate a non-executable schema. Of course, all the business logic that is in resolvers is not part of the introspection, but you can generate a schema from it and then use it as you wish. And with that, I thank you for your attention. If you have any questions or feedback, you can reach out to me on the Twitter handle linked here. And with that, have fun on the conference, and goodbye.